Okay, so today we are going to talk about our very first types of instructions from our instruction set. These instructions are called load instructions. Okay. Now, before I start, let's first look at what we know so far based on our previous lectures. Now, so far we have learned about the addressing mode. So that means just by looking at any instruction, we can tell what is the mode of the instruction. Okay. We can also tell what will be the object code. Okay. Sometimes the object code can be 1 byte, sometimes it can be 2 bytes, and sometimes it can be even 3 bytes. So what I did here is I wrote a couple of instructions. And at the left side, I wrote the object codes for each of the instructions. I just wanted to show you that this is what we know so far. Now, I actually left here 3 different cells. The reason is I left 3 different cells because the longest object code will be 3 bytes, right? And as you see that most of the instructions are just like 2 bytes here and 1 byte. So I think we know why it is 2 bytes and 1 byte. So at the left side, I also write some memory location. Now, by memory location, I mean that whenever you are writing the instruction, all these instructions are loaded into memory maps. Okay. Now, for an example, let's say if the instructions started loading from this address 0000, how do you count the address? Because remember, every single byte actually take one address location. Okay, because every location you can keep 1 byte. Now, for an example, so if this is the 0000, meaning address of this byte, this line. Interesting thing is the byte you have in that line is actually 2 bytes. Right? Look at this. The 86 itself is 1 byte. 02 itself is 1 byte, right? Because these are written in hex. Now, you might be wondering, so how do I write just one address and 2 bytes? So I actually did not do it. What I'm saying is the address of this line is 0000. Now, that actually means the address of always the first byte. Okay? Anytime if I just say, oh, address of this line is this, that means that is actually address of the first byte of the line. Okay, because in one line you can have 1 byte, you can have 2 byte, you can have 3 bytes. Okay, so that actually means the address of 86 is 0000, but address of 02, which is the next byte, is actually 0001, meaning the immediate next byte, right? Because it's always go in sequence. So following address, which is the address of 8B, would be 0002, which is also the address of the second line, right? Because remember, anytime if we just say address of second line, that means address of the first byte of second line. We don't always say, oh, first byte, but that's actually first byte. So 0002 is address of 8B. And then what is the address of 03? 0003, right? I'm just going in sequence. So the address of the next byte, which is 97, 0004, right? And this is 0005, right? And this is 0006. So that's how actually I got some addresses of each line, meaning addresses of the first byte of each line. Okay? So again, as you see that object codes are very closely related how we got the addresses. Because if I don't know this object code, there is no way I can find the addresses of the lines. And this is exactly how when you are writing the code and the codes are actually loaded in the memory locations in sequence. Okay? Because you need memory locations, I'm saying you need memories to load your code. Okay? So that's why we just showed you, okay, even if you have the object code, this is how the object codes are saved in the memory locations. It may not be starting from 0000 all the time. We'll talk about this in future lectures, but I'm just assuming that this started from 0000. So here is another example, pretty same, but in one of the instruction here is actually extended. So this is 3 byte. So if I count these addresses, again, let's start from 0000, then this is 0001, right? Then this one 0002, which is address of the second line, 0003, again 0004, the address of the third line, 0005, 0006, and now the address of the fourth line is 0007, right? So that's how we can always count, and we can exactly tell where the lines are starting, okay? All right, now let's look at a little bit more than what do you know. Now, so far we talked about the addressing mode, but we just can tell what is the addressing mode of an instruction just by looking at the address. So we don't know exactly any of the purpose of why we have some instructions has immediate mode, some instructions have direct mode, extended mode. We don't have any idea about that. Probably here you'll first get some little bit of ideas that exactly why we have different addressing modes and what are exactly the purposes of those. Now, in any instruction, when you see an operand, again, some instructions don't have operand like inherent, but other than inherent, if you see an operand, now operand actually means two different things. It can be either data or it can be an address. See, this is a little bit tricky here because all of these are actually binary numbers. No matter if you have data, no matter you have address, these are binary numbers. We write it in hex, but it's actually binary in computers, right? So sometimes so the operand look like same. I'm saying even if you're writing an address or if you're writing a data, it will look like a number, right? Because it's in hex. So, but how can I tell? I can actually tell based on the addressing mode. Now, addressing mode actually tells microprocessor two different things. Either it tells, okay, the operand itself is a data, or it tells, no, operand is an address. Again, don't forget that some instructions don't have operand, so that's something else. But I'm just talking about all the first three: immediate, direct, and extended, which have operand, right? Now, I put a little chart here that gives you a little bit of indication that how do I know it. Now, if my addressing mode is immediate, okay, that means my operand is a data. So no matter what, if the addressing mode is immediate, it is a data. And if you go back to your object code you wrote for last lecture, you will see that even in case of immediate, we had some instructions which were 1 byte, meaning which has 1 byte of operand. Some instructions we had 2 byte of operand. I'm talking about only the operand part, meaning the second part of the instruction. So basically I just wrote the length of data can be 1 byte or 2 byte because it varies, and you can see from the instruction that whether the data is 1 byte or 2 byte. In case of direct, your operand is always an address. In case of extended, that's also an address. What is the difference then? The difference is the length. Because in case of direct, the address, even if it is an address, the length is 1 byte. In case of extended, even if it is an address, it's 2 byte. But don't forget that the actually addresses are 2 bytes long. Meaning, remember at the very first class when we were looking at those very basic computer type, there was a little block diagram. We were talking about these, that it's a little bit funny because your data itself is all 1 byte, but to address the data, I'm saying to locate the data, we need address which are 2 byte longs. This is interesting. The addresses are 2 byte, but the data itself is 1 byte. The reason was because we wanted to point more locations, so we needed a little bit longer. Remember I was just telling, if you have just 2 byte, you can at max write 0 to 3, only like in binary, right? So 0 to 3, you can just write 4 numbers, right? So if you have 4 bit of binary, you can write 16 numbers, 0 to 15. So the longer you have, the longer accommodation you have, you can actually accommodate more addresses. So that's why our address bus is 16B, right? Meaning 4 bytes. I'm saying 2 bytes. So now let's look at a little bit more. So at this point, this is what we know. It is if the instruction is immediate, there's data. If not immediate, meaning direct or extended, it's address. And in case of inherent, we don't have operand, so I left it blank. Okay. All right. Let's recall that we have several registers, right? We listed those here in a little bit extended form. So here we have list of all the registers that we will be using for this class. Now, again, remember, if you recall, the registers itself has a length, right? Because some of the registers were 1 byte long. Most of the registers were 2 byte long. Okay? As you can see in this list, only the accumulator A and accumulator B, those are 1 byte each. But except these two, starting from the accumulator D, index register X, Y, stack pointer, SP, program counter, PC, and the condition code register CCR, all of these are, I'm saying, except the condition code register CC, but up to the program counter PC, everything's at 2 byte. And the condition code register is a little bit different kind of register. We'll talk about this at some point. This is 1 byte. And if you look at the very right side, I also wrote the type of the register. Now by type I mean that if the type is physical, that actually means that these registers exist physically. Okay? Now all the registers are actually physical except one. One of the registers is written logical. Now the logical actually means there is no accumulator D actually. Okay? But why we write accumulator D? Because sometimes in some cases we need longer accumulator than 1 byte. So we write accumulator D, but anytime we write accumulator D, your microprocessor assumes you are actually combining A and B. So D does not exist. Whenever you say D, that means A followed by B. You see what I'm saying? So basically D is a combination of A and B. So there is no D in reality, okay? But we use D, we write D, we have instructions with D, but D does not exist, okay? It's actually logical, you know. But when you will be writing the code, you have to know it, but that doesn't make a big difference, except, you know, applications and purpose of the whole instruction. Let's look at the load instructions. These are the very basic and very important kind of instructions, because without loading, there is no way you can write any program, okay? Now, what is exactly the loading? Loading actually means that, for an example, before you do any operation, okay, what happens? You have the instructions which are loaded into memory map, but you have to pull the instructions from the memory map to the registers. So again, here the load instructions. These are the list of all 6 load instructions that we have here. Now the load instructions again is very important, because load instructions are the one which tell you that before you do any operation, what happens? All the data you are working with are actually in the memory, right? And the way we do the operation, we actually bring the data from the memory to the accumulator or to the registers. Accumulator is also like a register, right? We actually bring the data there. So that is actually called, in computer language, that is called loading, okay? That means you will be by loading, we always tell that, okay, you are bringing the data from the memory to the register, because you always have to bring it first, then you do whatever, let's say addition, subtraction, multiplication, whatever you do, okay? So that's why you realize now that why the loading is so important, because if you don't load, I'm saying there is no way you can do the operation, okay? So you first bring the data from the memory location to the register, and all of these are actually some sort of loading, okay?
I think we're taking it from wherever it stays in the memory to the CPU. Is that what's
Yes, yes. And all the registers are there, okay? So, and all the registers mean, remember the registers you just looked at in the previous slide and in some previous lectures as well. Now here, let's say the first instruction, LDAA, and there is an operand. We don't know what is the operand right now because we are not writing the instruction. That actually means you are loading the data into accumulator A. And since, as I said, the accumulator A is 1 byte, So definitely you are loading 1 byte of data, right? And same is for the next one, loading the 1 byte data from memory to accumulator B. I did not write from memory everywhere because it's same, because it's always from memory to register, okay? Now the third one is from memory to accumulator D. Now recall that accumulator D is actually 2 byte. So when you are saying loading for accumulator D, so you'll be loading 2 bytes since the register itself is 2 byte. And same is for index register X, index register Y, and stack pointer S. All of these are actually 2 byte registers. So when you will be loading for these registers, the data will itself be 2 byte. Okay. Now, as you, I think now you can see why we are talking about the load instructions at the very beginning. Okay, because there is no way you can do any operation without loading, because you have to first bring the data from memory to register, and then you do some operation, and then once you got the result, or whatever you are doing, you got the answer of it, then you actually put that data back to memory. That's exactly how it works. Anytime you need to do something, you bring the data from memory to register, do something, finish the work, get the result, and put it back to the memory location. Okay. Now let's look at a couple of more examples. Now let's try to see whether I understand this instruction. Now this is a load instruction again. Now we know this is a loading, and loading into accumulator A, right? Now, first of all, what is the addressing mode? Of course, immediate, right? And this is for sure data, right? Now we know this is a data. Remember, if the addressing mode is immediate, operand is for sure data, okay? Now we know it, of course. Okay, what is the number system here? Meaning, is the data given in decimal or hex? Decimal. It's of course in decimal, right? So anytime something is in decimal, we always convert it back to hex, just to, that's our default thing. So I convert it back to hex. That becomes B1, right? Since I converted back to hex, I put a $sign. That's how we always know that this is a hex number. And what is the action taken since you're writing the instruction? The action is taken is B1 is a data, 1 byte data, right? Which is loaded into the accumulator A. Now there is a little bit of tricky part here. In case of immediate, your data is actually given in your instruction, right? You see here, this is your data which is given in the instruction. So in case of instruction, I'm saying in case of immediate instruction, we actually do not load directly from the memory. We already have the data in the instruction. Okay, so that's why in most of the load instructions, I did not always write from memory, because sometimes it may not be exactly from the memory, but because in instruction may have it if it is an immediate mode. Okay, so you have the instruction. I'm saying you have the data, you load it directly, so you don't need the memory. Okay, you don't have to even look at the memory, what you have in the memory. Okay, since you already have the data, and all you are doing is just loading the data into accumulator. Okay, since it is accumulated, because since it is saying load into accumulator A, and that's 1 byte, and you have the 1 byte data here. Let's look at another instruction. Now this is again a variant of the instruction. Now can you tell me what is the addressing mode of this instruction? No, addressing mode is direct, right? So that actually means everybody agreed, right? This is direct. Now this is direct, so that means this is an address, right? Now if this is an address, we can always convert it back to, we don't know exactly what to load right now. Why? Because we don't have the data. Do you see the point? So at this point, in the previous one, we knew that was the data, we just loaded the data. Remember, we always load the data, we don't load the address. So we know the address, but we don't know the data. Now, how it is given, decimal or hex? Of course decimal, right? Now we can always convert it back to hex. Now it becomes B1. Now in these questions, you need to know what you have in the memory. Okay? That's why we give you a memory map for such question. We actually will give you a memory map with every question, whether you will need it or not. Okay? Memory map actually looks like these. See, there is a big map here. At the very left column, you have all addresses. These are all addresses, and that's why you see all of these are actually in 2 byte, right? You see the very left column, okay? Now, everything else in the middle, I'm saying starting from the second column to the end, is all data. Now, how do I read it? This is how I read it. See, these addresses here are actually the addresses of the very first byte. So for an example, what is the address here? Can you read it? 0010, right? Now that is actually the address of the very first byte, which is 58. This 58 is a data. The address of 58 is 0010. Now what is the address of 96 then? Exactly, 0011. Now let's read it. 0012, 0013, 14, 15, 16, 17, 18, 19. What is the next one? 1A, because this is hex reading, right? Then it is 1B, 1C, 1D, 1E, 1F, and just right after 1F, you have 20, right?
Yeah.
So basically, this byte is the very next location of this byte.
So that number 58 is 0010.
0010, yes.
Okay.
No, I'm talking about the very last one.
Yeah.
So this one is 001F, right?
Yeah.
So very next one is 0020, which is this one.
20.
Yes. Now from here, can you now find where is B1? See, this is an address, right?
Yeah.
B1 is an address. Can you find B1 from here? Now look at this here. This is B0, right?
Yes. 2B. Okay.
So that's my B1 here. So I got the data from there, and that is actually loaded into accumulator D. Because whenever you are given an address, you have to look for data in the map.
Oh.
Because you don't have the data in the instruction. You are given an address, so you look for data in the map. So now you know how to read it. So this is 00B0. So the next one is 00B1, and that is loaded into instruction. And again, as I said, at this point we are loading into accumulator A. So we are just taking 1 byte, right? Because we have just 1 byte there. Any question up this point? Let's try some next, another one. Okay, we have another instruction here.
Wait, can we go back 1 second? Just 1 second. Okay, so B1. So like, let's say that's the homework, and it says what data are loaded into the indicated register, and that's the one that we have right there.
Mm-hmm.
So how would we write that to get that answer right?
Just 2D.
Just 2D.
Yeah, because we just want to know what is the data. Yeah.
Okay, gotcha.
Mm-hmm. All right, let's look at the example 3, another instruction. Again, what is the addressing mode? That will be always the first question, because otherwise you cannot answer anything, right? Now we know this is immediate, so this is data for sure. Okay, this is not given in hex. We convert it back to hex. Now, once you know the data, you can load it into the location, right? Now, what is the register right now? If you look at the register, this is index register X. Now, if you go back to previous slides, the index register X is actually 2 byte long. Remember, all the registers are 2 byte long except accumulator A, accumulator B, and condition code register. Everything else 2 byte. Okay. Now, here is the catch. If you look at the data in the instruction, is given in 1 byte, right? Look at the instruction. It's 1 byte, right? B1. But you are trying to load into index register, which is 2 byte. So you actually have to fill the first byte by 00. Because you can always add as many 0 as you want at the beginning, right? But make sure you don't add at the right side. You always can add at the left side, right? You can just add, okay, 20 following B1, that is still will be B1, right? So be careful in these situations, because even if your instruction tells that load B1, actually the data will be loaded is 00B1. Do you see what I'm saying? Because the register itself is 2 byte. You cannot leave something blank in the register. You cannot just say, oh, okay, I'm just loading B1, but I'll just leave one byte blank. You have to load 2 bytes, okay? Now, again, in this question, excuse me, we have not looked at the memory map. Why? Because we know the data, which is given in the instruction, right? If it is immediate, you actually don't need the memory map. But but remember, don't get confused. In pause, we give you map in every question. You may need it, you may not, but we give it to every question because we just want to make sure that you know that this time you don't need it, but you still have it. Okay, now, in this question, let's say if you are answering this question in pause, what data will be loaded into index register X or indicated register? You'll be writing 00B1, not only B1, because we want to make sure you understand that what will be loaded in full. Okay, you may write B1, you will probably get partial credit, but that's what we need to know, that it has to be 2 byte.
So the previous one, the answer is only B1,
Mm-hmm.
and this one's 0. How do you know that you have to put the zeros in front of it? Because it's
The register itself is 2 byte. How do you? I'm saying your data is 1 byte. How do you feel it? Register itself is 2 byte. Mm-hmm. And that's why, see here, I actually wrote 2 cells. Any question here?
How do we know it's accumulate A or B?
Oh, it's not accumulator A or B. This is index register X. So if you go to the set of instruction, if you look at the column 2, you'll see a description there as well.
Yeah.
Look at every instruction. So if you find, let's say, LDX, check the second column.
The operation. Yes.
Load index register X, right? So you know it from there. I also listed in one of the slides for all the 6. Remember all the 6 instruction? I actually wrote where to load. Okay, load into this, accumulator A or accumulator B or C, D. I just wrote it here, right? See, all of these are here. So if you just hear LDX, load data 2 byte in index register X. What is exactly your question? You may not be loading into accumulator. You may be loading into index register X. That's still okay. I'm saying we have different, 6 different instructions to load into 6 different things. So you are not always loading into accumulator A or accumulator B. You might be loading into X. You might be loading into Y. You might be loading into SP, meaning stack pointer, right? Because there are 6 different types of load instructions we have. Any question here? Okay, if not, let's try another one. How about this one? Now we know this is an address, right? Because this is direct. This is an address. Now what will be the data then? Now if you look at carefully, we are trying to load into D, right? Let's recall what was D. D does not exist, right? D means actually A followed by B, right? And that's why instead of writing D at the action, I actually wrote accumulator A followed by accumulator B. Because that actually means D, right? All right, now this is an address. We don't know the data yet, so we have to look at the memory map, right? Let's go to the map. Do you see it? See it? Now, this is B1, right? This is my B1. Now, since you need 2 byte this time, because you are loading for D, right? We automatically take the next byte. So we start from B1, okay? And then we take the B1 and the next byte, which is B2. So basically, we take 2D, 40, both bytes, because we need 2 bytes from the memory map. Remember, in the instruction, you will be always given 1 address. We cannot give you 2 addresses, but you know that where you need to start. So since you need 2 bytes, you start from that byte, you take next byte as well, because you need 2 bytes. Because you are filling accumulator B. And as you can see, when you are trying to fill accumulator D, meaning you are trying to load something into accumulator D, you'll first load the first byte into A, and second byte goes to B, right? Basically, even if you are loading accumulator D, you are actually loading into A and B. A followed by B. Any question here? Okay. So we pretty much, oh, what is the question?
What would that be there if there's no go?
How it is direct? I think direct is always like this, right? There is no pound sign. No pound sign means direct or extended, right? And if it is 1 byte, that's direct, right? Okay. And again, it was actually 177, right? We just converted to B1. And we know that 177 was decimal, and it was less than what, 255, so you know, that's less than or equal to 255, so we know this. Okay, now, if we don't have any question, we are ready for the quiz. Now, in the next quiz, which is quiz 3, in every question, you will be given an instruction, okay? And each of the instruction will be load instruction, meaning one of those 6 load instructions, okay? Now, what you need to tell is what data will be loaded into indicated register. Now, what is the indicated register? Based on the instruction, it can be accumulator A, accumulator B, or accumulator D, index register X, or index register Y, or a stack pointer S. But remember, except A and B, all other registers are 2 bytes. And we also have the list of registers here with all the bytes, so you know exactly which registers are 2 bytes. And I don't mention CCR all the time. The condition code register is a little bit different types of register. So that's why most of the time I talk about the accumulators and the index registers and other ones except the CCR. But at some point we'll talk about the CCR, which is 1 byte. But the purpose of CCR is a little bit different than the other registers. So that's why we do not always mention, oh, CCR is 1 byte, okay? But that is also 1 byte. Any other question? Okay, let me stop here and let's go to the quiz section and let's try quiz 3. Again, as you probably realize by now, everything you are learning is extremely important when you are trying the next, you are making your next step. Because when you are answering this question, look at this. Every time we are asking, what is the addressing mode, right? So if you don't understand addressing mode, there is no way you can actually answer this question, okay? So similarly, whatever you are learning here is extremely important to understand the next step. And that's why we make a very little step every time in this class so that we understand it, and then we are ready for the next topic, okay? Let's go to the quiz 3 and let's try the questions. Again, in each question, you'll be given a load instruction, and you have to tell what will be the data loaded. Remember, if the data is 2 byte, write 2 byte. If the data loaded is 1 byte, write 1 byte. No matter there is a 0 at the beginning, you have to write those, okay? And make sure you read the question carefully, okay? Because some of the question we mentioned, what will be loaded into accumulator A? What will be loaded in accumulator B? So make sure you see the question carefully. What is the question is asking, and where you are loading. Let me stop this presentation here.